Hello everyone. For this tutorial video, I'd like to give a mathematical definition of what critical points of a function refer to. A critical point is any point where the derivative is either zero or non-existent. But the catch is, the function itself must always exist at critical points, even if the derivative may not. For example, if we were asked to determine the critical points of 6x minus 4 times the cosine of 3 times x, we would compute the derivative as 6 plus 12 times the sine of 3x, set this to equal 0, and solve for x. We see, because it is a trigonometric equation and we are not limited to a specific interval, we have literally an infinite amount of critical points, which agrees with a graph of this function, as we can see visually that there are an infinite amount of points, where the rate of change is 0 or flat. However, it is important to notice that not all functions will guarantee a critical point, as in this example. We compute the derivative of function of x equals x times e to the power of x squared. We see this as 1 times e to the power of x squared plus x times e to the power of x squared times 2x. By the product rule and chain rule, we see e to the power of x squared is a common factor and we can isolate it. And we can see, in its most simplest form, that the function will never actually be 0, and it does not have any conditions to guarantee that it won't exist either, i.e., there are no divisions by 0 or anything like that. So in conclusion, because the function always exists and never equals 0, the function has no critical points, which if we sketch a graph of this function, we can confirm. The reason these types of x values are called critical points are because they are important or critical to determining not only where the function is flat, but also to determining the minimum and maximum values of a function, which is what we will investigate in later tutorials. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.